Okay, let's dive right into this explainer and reveal exactly how you can stop losing those easy, avoidable marks on SQL DDL, primary and foreign key constraints in your Cambridge exams. Listen, I want you to approach today's session with a very specific mindset. I want you to think of yourself as the John Wick of Cambridge computer science, because when you are pushed out of your comfort zone by a complex, multi-part database question, you do not panic, you push back, and you do it with perfect, methodically structured answers. Today, we are staring down the ultimate grade boogeyman, data definition language, specifically looking at the intricate interplay between primary and foreign keys. I want you to consider a classic past paper scenario, subject code 9618. Picture two students. On one hand, we have a student we'll call Alex. Now, Alex overloads their answer with raw computer science facts. They write lines and lines and lines of SQL code, but there is absolutely no analysis. There's no justification of the data types and zero explanation of the relational links. It's just a data dump. On the other hand, we have Sam. Sam rushes the exam. The clock is ticking. Sam sees the phrase foreign key, completely panics, ignores the command word evaluate, and entirely misses the specific requirements of the scenario. When you look at their papers, there's red pen everywhere. Those lost marks bleeding all over their answers, those are the marks they literally just threw away. But today, right now, we are going to fix that. We have organized this entire masterclass into a clear, structured playbook. It covers both the technical theory and the practical, hard-hitting strategy you need to secure top marks. We're going to break down the exact traps that caught Alex and Sam, establish the core DDL principles, walk you through a procedural framework, show you how to secure your method marks, heed the direct warnings from examiners, and finish up with the ultimate exam strategy. Let's get into it. So, Section 1, the lost marks trap. Let's look at why so many students fall short right out of the gate. This question on your screen is exactly what we are going to answer first, because understanding the distinction between similar database concepts is where this battle is won or lost. When you look at syllabi across the entire Cambridge spectrum, whether you are building those early foundations in 0417, 0478, 0983, 0984, or 2210, all the way up to the advanced rigors of the 9618 paper, the fundamental reason students lose marks remains exactly the same. They treat SQL DDL as a simple vocabulary test instead of an applied engineering problem. Let's go back to our student Alex for a moment. Alex's answer for a massive 4-mark question was simply this: a primary key is unique, a foreign key links tables. Now, I want you to ask yourself, is that true? Yes, technically. But is it a 4-mark A-level answer? Absolutely not. It completely lacks depth. It lacks evidence. Most importantly, it lacks the why. To get those marks, you need to break down the specific computer science assessment objectives. You've got to decode the command words. If the question says explain, you cannot just state. And this brings us to the most powerful tool in your entire exam arsenal, the PEEL framework. That stands for point, evidence, explanation, link. Top students structure every single written response using PEEL. They make their point about the constraint, provide evidence by writing the specific SQL DDL syntax, explain the technical impact of that constraint on the database's integrity, and finally, they link it back to the specific context of the question. Now, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's move into Section 2, SQL DDL core principles. We need to establish the rules of the game. Having a conceptual, highly transferable understanding of primary and foreign keys is required to tackle the completely unfamiliar contexts that Cambridge is going to throw at you. In SQL DDL, when we use the create table statement, adding a primary key constraint isn't just about tagging a field for the fun of it. It is a fundamental, non-negotiable declaration of entity integrity. You are literally telling the database engine, listen, this attribute or combination of attributes will uniquely identify every single tuple in this relation, and it absolutely cannot be null. Period. Conversely, the foreign key constraint is the absolute cornerstone of referential integrity. It is a structural tether. When you write foreign key, department ID, references, department ID, you are creating a strict, almost biological dependency between two tables. You are preventing orphan records. So if we apply our PEEL framework here, think about how this works. Your point is that the foreign key maintains referential integrity. Your evidence is the specific SQL syntax references. Your explanation is that it prevents a rogue user from inserting a record with a department ID that doesn't actually exist in the parent table. And your link connects it to whatever real-world business scenario the exam paper just gave you. To really understand the difference in quality, let's look at two answers side by side. Answer A says, the primary key stops duplicate records. The foreign key connects to the primary key in another table so you can join them in queries. It's okay, but it's weak. Now look at answer B. Answer B says, whereas a primary key constraint enforces entity integrity by ensuring a unique, non-null identifier for each record within its own table, a foreign key, in contrast, enforces referential integrity by requiring that the value entered must already exist in the referenced parent table. For example, a student cannot be enrolled in a course ID that does not exist in the course table. Wow. Answer B thinks exactly like an examiner. Why? Because it uses comparative connectives and the Peel framework to secure full marks. Words like whereas and in contrast are those comparative connectives. Answer B didn't just list off facts, it actively analyzed the relationship between the two constraints. And this is so crucial because the syllabus explicitly targets these three cognitive domains, meaning your rote memorization simply isn't enough. You must analyze and apply your knowledge. This framework right here is your roadmap into the examiner's brain. At the absolute baseline, we have knowledge and understanding. That's knowing that in primary key is the correct syntax. It's totally necessary, but honestly, it only gets you the bottom tier marks. Moving up, we hit application. This is where you encounter a highly complex, completely convoluted data dictionary provided in the exam. You have to identify which fields need to link and write the specific, customized SQL DDL code to make it happen without any syntax errors. And finally, the gold tier, analysis. Analysis is when the exam asks you to evaluate the implications of removing a cascading delete constraint on a foreign key. It is where you have to foresee the ripple effects of data manipulation across the entire relational schema. If you only study the baseline knowledge, you are permanently capping your grade. You must practice application and analysis relentlessly if you want to be at the top. Let's move on to Section 3, the procedural framework. This is all about algorithmic thinking. Algorithmic thinking in SQL requires you to follow these exact 4 steps to ensure a methodical and efficient solution. We are going to transform Alex and Sam's messy papers into perfect answers using this computer science success blueprint. First up, step-by-step decomposition. Remember how Sam rushed the command word and panicked? Instead of freaking out, Sam should have decomposed the problem. Identify the parent table, identify the child table, identify the exact primary key in the parent that will serve as the target for the foreign key. Simple. Second step, data structure selection. Are the data types identical? A massive trap students fall into is trying to link an integer primary key to a varchar foreign key. The database will reject it immediately, and trust me, so will the examiner. Third step, efficient implementation. This is where you actually write your create table statements, applying the constraints accurately based on your decomposition. Finally, the fourth step, rigorous testing. Now, obviously you can't run code in a written exam paper, but you absolutely must mentally test it. You have to sit there and say to yourself, okay, if I try to delete a record in table A, what happens to table B? By walking through this blueprint, you are transforming raw, chaotic thoughts into a highly structured, incredibly scoreable response. All right, Section 4, maximize your method marks. We're talking about the exam safety net. Stop scrolling, subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Now, this quote is huge. Examiners actively award marks for your process, so never ever skip showing your clear, systematic working. Let's talk about what showing your working actually means in the context of SQL DDL. Let's say you write a really complex create table query with multiple foreign keys, but you're nervous and you accidentally forget a comma or you misspell references as references without the E. In the real world, the compiler throws an error and your code fails, but Cambridge examiners are instructed to look for your intent and your method. If you have explicitly annotated or structured your answer to clearly show you understand exactly which field is acting as the referential link, you will secure the method marks. If you just write a jumbled block of code, cross things out, and get the syntax wrong, you get 0. But if you quickly jot down a schema diagram or write a 1-sentence comment next to your code saying, linking employee ID to branch table to maintain referential integrity, the examiner clearly sees your methodical thinking. You have provided the evidence of your cognitive process. That right there is how you build an unbreakable exam safety net. By following this standardized 5-step sequence, you virtually guarantee process points. Imagine a 60-second timer on your screen right now, and you're doing a rapid data scan of a complex table. You see a customer ID that is a 5-character string in the customer table, but wait, it's listed as an integer in the orders table. Catching that mismatch during your Step 1 data scan prevents a critical flaw later on. Once you spot it, you quickly draft the logic using the Peel method.
The foreign key enforces referential integrity by preventing orders for non-existent customers. This ensures the business never ships products without a valid billing profile. Bam! You just locked in full marks by being methodical. Let's transition over to Section 5, Top 3 Examiner Warnings. This is all about avoiding the pitfalls. Examiners are actively, aggressively penalizing vague answers and a lack of specific edge case checking, so precision needs to be your absolute best friend here. A critical trap that catches even good students is ignoring boundary conditions and edge cases. In SQL DDL, an edge case isn't just a tiny programming error, it is a massive structural logic failure. An examiner will give you a scenario where a company wants to delete an old product line from their database. The boundary condition you have to check is what happens to the historical sales records in the sales table that have a foreign key pointing to that deleted product. If you don't mention on-delete cascade or on-delete restrict in your DDL analysis, you are completely ignoring the edge case. A top-tier John Wick student writes, "We must define the boundary condition for deletion. If a product is removed, the foreign key constraint must restrict the deletion to prevent the loss of historical financial data, maintaining the integrity of the audit trail." That is how you use technical specifics to totally obliterate a question. Vague answers just say the database might break. Precise answers explain exactly why the referential integrity fails at the boundary condition. Because ultimately, if your answer isn't firmly rooted in the specific context provided by the question, you are leaving major points on the table. Let me repeat that because it is vital. Context is king. Cambridge examiners do not write generic questions for fun. They don't just ask you to write a DDL statement. They will give you a detailed scenario, a hospital patient management system, a logistics tracking network, maybe a university enrollment database. If your written explanation of your SQL code reads exactly like a textbook definition and never once mentions patients, cargo, or students, you lose the application marks instantly. If the database is for a pharmacy, your explanation of a foreign key must explicitly state the foreign key linking the prescription table to the medication table ensures that a pharmacist cannot accidentally prescribe a drug ID that is not officially registered in the system. You must weave the fabric of the specific scenario into the technical syntax of your answer. This applies universally, whether you are studying the foundations in 0478 or pushing the intense advanced analysis required in 9618. Which brings us to our final part, Section 6, the ultimate exam strategy, critical analysis. The highest scoring candidates, the ones setting the curve, don't just write code. They evaluate alternatives, compare approaches, and provide justified recommendations. To hit 100% mark potential on your exams, you need to master the 3 rules of our complete computer science answering system. Rule 1, command word decoding. You must tailor your depth of response precisely to whether the question asks you to identify, describe, explain, or evaluate. Rule 2, Peel framework application. Never, ever write a descriptive paragraph without a point, technical evidence, structural explanation, and a contextual link. Rule 3, the time management matrix. Do not spend 10 minutes writing a novel for a 2-mark knowledge question, and definitely do not rush a 6-mark analysis question like Sam did. When you evaluate a DDL schema, consider the real-world trade-offs. What is the limitation of strictly enforcing a foreign key if the database needs to accept temporary, incomplete data imports from an external legacy system? By acknowledging these real-world database limitations and justifying your design decisions with concrete SQL evidence, you transcend from being just a student to being a database architect in the eyes of the examiner. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. In your next practice paper, will you just write the SQL code, or will you justify your trade-offs and check your edge cases? The choice is yours. Push back and go ace that exam.